Welcome to the lecture 7 of the series, Psychology of Well-Being. Today we are going to look at one of the two methods that we generally utilize in the research on well-being, one of which is correlational method, primarily statistical one. And we are going to see that how this method helps us cater to the promise of the positivist or the post-positivist paradigm or the natural science paradigm in trying to understand the relationship between various variables such as well-being and other variables that might be associated with well-being. So let's try to take a look at what are the important elements of this method that we are going to understand. Well, we are going to begin with a revision of the basic assumptions of the natural science or the positivist paradigm. And then we'll try to look at the very idea behind the correlational method, which is that of relatedness or association of various kinds of variables pertaining to well-being. Importantly, we'll also look at the correlation coefficient, which is nothing but the index of strength of relationship between different variables, particularly two taken at a time. That's the general correlation process that we happen to understand with the help of Pearson R. Then we'll look at another aspect of the correlational method, broadly speaking. The correlational method also includes linear regression analysis that helps us understand prediction on the basis of association between different variables with the help of the prediction line or the line of best fit. How we derive that line of best fit, that would also be something which would be a part of this learning today. And then we'll look at that, beginning with, as we began with the correlation coefficient between two variables, and then linear regression, I beg your pardon, between two variables, which is also known as bivariate regression. We move on from there to multiple regression, which tells us about how we can predict one variable like well-being, also known as a criterion variable, with the help of various other predictors or the predictor variables. So we'll take the example of that also. From there on, we'll see that is the association between the predictor variable and the criterion variable also somewhere intervened or mediated by another variable. So that would be some interesting understanding that we'll be broadly developing with the help of this broad method called the correlational method. Okay, so very quickly, let's do a recap of the natural science paradigm. It tells us about the existence of reality out there to be discovered towards universal generalizations. And here we'll be talking about generalizations in terms of relationship between different variables. Then epistemology, distanced or hierarchical relationship between the knower and the knowable. Methodology, experimentation or survey with the help of neutral observation or data collection procedures using variables about the phenomenon under study. So here we are going to make use of how survey method will help us collect the data regarding various variables, and then we'll be utilizing various kinds of statistical procedures to try and understand the strength of association between various kinds of variables under study, primarily within the domain of well-being that we have been looking into in this particular course. Okay, and then particularly axiology, it's generally decided by the research on the basis of existing literature or proposed research, which basically means that what purpose the research findings generally would serve to the research participant, that's usually decided by the researcher on the basis of literature and proposed research. Okay, so now what is correlational method, and how does it help in the study of well-being? So that's the broad question that we should take up right now. And it begins with the idea of relatedness or association between various variables. Let's take some concrete examples. Well, let us consider a question that teachers and students, also their parents, of a university are concerned about. And let's take up this particular one. Is cumulative performance index in that university that tells us about the performance level, academic performance levels in various courses of students. Also, the acronym CPI stands for Cumulative Performance Index. And how is that related to, or is it related to, their experience of well-being? Well, specifically, we can ask this question, does increase in CPI necessarily mean enhanced well-being, or does a dip or decrease in CPI necessarily mean lower well-being? So these are the questions that may come to our mind, and we find that it may help to utilize correlational method for that. So we'll be very soon looking at some simulated data about a set of 20 students from that university to try and answer these questions which pertain to the relationship between CPI and well-being. So let's take a look at the data now. Well, on the left-hand side, we can find that we have the CPI scores in terms of how their performance can be rated with the help of the performance in various courses in terms of the value from 0 to 10. And then we also have the data, the simulated data related to the students' well-being, the same set of students, that the score ranges from, again, 0 to 10. Now, let us try to have the scatter diagram. Okay, so this is how we can plot the data from these two variables, CPI and well-being. But the key question is, are we able to observe any pattern of relationship between well-being and CPI? Well, doesn't seem to be so, apparently at least, because we can see that if we take a look at x-axis, that is CPI, and we go up to, let us say, 6, we find that around 6 CPI, the range of well-being scores are from 9 to 1. So that tells us that with, let us say, one particular value, we have got a diverse kinds of values for well-being amongst these students. And when we move towards 8, let us say CPI 8, we find that there also there's this range which goes from well-being score of 4 towards 8. So it seems that more or less it's difficult to take a call on whether or not, particularly, there is an increase in the value of CPI with an increase in the value of well-being, or vice versa. Now, how to address this particular question more systematically? Well, although there seems to be no specific pattern, as we just saw, of relationship between well-being and CPI from the scatter diagram, it is difficult to be sure about any specific answer about the relationship between the two variables. Well, will it help if we have an index of measure or measure of the relationship between well-being and CPI? I think yes. And this is where we find that the correlation coefficient comes in, which is derived with the help of this particular formula. When on the numerator, we basically find there is this formula for covariance where we try to have summation of x minus x bar multiplied by y minus y bar, and denominator consists of, again, the variances or the formula that resembles variance, where you find that is the variance of x and variance of y square root, and they are multiplied. So that's the formula for finding out correlation coefficient, I beg your pardon. And we find that it involves, again, the covariance as well as the variances of the two different variables. Okay. Now, there is some more information on this, that the range of this correlation coefficient, that is R, is -1 to +1, or -1 to +1. Now, R values close to 0 represent no association between the variables x and y. Okay, so if we get a score of 0 from this formula of R, we find that there is no association between the variables x and y. The R values close to the extremes represent strong association, that is -1 or +1. If it is closer to that, we find that there would be strong association. Then we also need to understand that the positive value of R, for example, let us say plus or positive 0.75. So that means a positive association between x and y, that is, an increase in the value of x is generally observed with an increase in the value of y. Similarly, a negative value of R, for example, let's say negative 0.75, means negative association, that is, an increase in values of x is generally observed with a decrease in the value of y and vice versa. So with this set of information, let's try to look at our data of CPI and well-being once more. Okay, and we could find with the help of that formula of Pearson R that it is 0.063, which basically means that the association or the strength of association between CPI and well-being is not strong. It's almost, let us say, 0. So an increase in CPI doesn't necessarily mean, or generally doesn't mean, that it would actually be associated with an increase in well-being, or a decrease in CPI doesn't necessarily mean that it will decrease. It will be associated with a decrease in well-being of the set of students about which we have the data, the students from the university, from one of the universities, and we had the simulated data regarding them. Now comes another question. So let's look at how the association between well-being and a sense of achievement from usual activities within the university for the same set of students. Let's look at the data and the results and try and see that is it again 0.063, just like well-being and CPI, or does it tell us something else? Well, here is the score on sense of achievement, which again ranges from 0 to well, again, something very close to 300. And we find that there are a whole range of scores of these 20 students, and simultaneously we have the same data on well-being. Let us look at the scatter diagram, and we find that there is some pattern general that indicates that yes, with increase in sense of achievement, we find that some increase in well-being is also noticed here in general. And when we apply the formula to calculate Pearson R in terms of whether it is close to 0 or close to the extremes, let us see what extremes again means that whether it's close to +1 or -1. Let's try to see that what does the result on Pearson R value indicate. So R, or the correlation coefficient for well-being and sense of achievement, for this set of data is 0.96, which is very, very close to +1, which basically means that one can observe higher values on well-being, higher experiences or better experiences on well-being, as the sense of achievement in the activities within the university that the student involves in. So that increases. So that sense of achievement, again, is positively associated, strongly positively associated with a sense of well-being. So that's the uh, simulated data regarding sense of achievement and well-being, and we find that it makes sense to make use of correlational technique, particularly in finding out the correlation coefficient that gives us the range of values with which we can interpret the association between the two important variables related to well-being. All right, if that is understood well, excuse me, then let's move on to another technique within the correlational research, and that's taken to be linear regression analysis. That involves prediction on the basis of association. So what does it say? If there is an association between X and Y variables, as we saw between well-being and sense of achievement, can we predict the change in values of Y as a function of a unit change in the value of X, that is predictor variable, and Y is taken to be the criterion variable. So that's the question that we ask in the linear regression analysis. Well, linear regression analysis, again, is utilized in studying such prediction. Well, we take help of the formula of a line, that is y equals mx plus c, where m is the slope of that line that it makes with x-axis, and m is nothing but the um, tangent function of that angle that the line makes with the x-axis. So we are familiar with that. So that's y equals mx plus c. Now the question arises, how do we derive this line and its equation from the values of x and y? Because we find that generally these are scattered on the scatter diagram. It doesn't follow a line specifically. So this is where we get back to the previous example with data about well-being and sense of achievement. Let's see how it can be done. So here is the data once again. And here is the scatter diagram. And within that scatter diagram, we find one dotted line for which we can easily understand the formula can be y prime. Y prime we are saying because it is the line of prediction. Okay, so when we talk about y prime, these are the predicted values with the help of estimation that will be very quickly, very soon going into. And again, that y prime will be equal to mx plus c. So that generally follows, the prediction line follows the formula for a line. Now, let's look at the top right corner of this particular slide, and we find that there are two values given there. One in black, that is yi. Another one is y prime I. What do these two values indicate? Now, yi is nothing but the raw data that corresponds to, I think, the 21st serial number 21, although the serial number column is not given on the left-hand side table, but we can see that these values are given in blue color, 200 on x-axis and 9 on the y-axis. So we find that, again, that yi actually represent the value of 9 on y-axis, and there is corresponding y prime I that is on the line of prediction. Okay. Now, the way to derive this particular prediction line, because we are assuming that if there is a prediction line, then there would be a corresponding value of yi on that prediction line itself, which is represented in red color y prime I there on the right-hand side corner of this particular slide. Now, if we have understood that well, then the least square procedure is applied to try and find out this prediction line. How does it happen? The minimum value of summation yi minus y prime I whole square, okay, is derived using calculus or differential calculus, and that decides the equation of the prediction line or the line of best fit. So with the help of that derivation, we finally have the y prime equals mx plus c, and we can see that for this set of data, using the least square procedure, the equation of line of best fit for this set of data is y prime equals 0.036x, and 0.036 is nothing but the slope or the value of m plus c, and c is 0.13. Now this helps predict the value of y, that is well-being. Actually, it should have been y prime there, I beg your pardon, from any value of x with the help of this particular formula, with the help of this particular equation of the line of prediction that we could draw utilizing the least square procedures described in this particular slide. All right. Now, from there on, we move on to a particular situation where we just don't have two variables like sense of achievement as the predictor variable and well-being as the criterion variable. So we may have more than two such variables there. Okay, so in the previous case, as I just mentioned, we had one predictor variable, that is sense of achievement. But if we have more than one predictor variable in the study where y or the criterion variable is taken to be well-being, then we'll have to consider a situation with the same least square procedure that we adopted earlier, and we'll have data from final year students to take an example for understanding multiple regression analysis, where we have got more than one predictor variable. So these students about which we'll be having simulated data, so they have got their placement. So they've got their projected salaries in front of them from the same university. So we have Y as well-being, then X1 is salary package in thousands, 1,000 rupees per month. Then X2 is sense of achievement from activities within the university, as we noticed in the previous example of general regression model with two variables, one predictor, one criterion. And then X3 is gaming addiction that many of the university students, some of this university student might be going into. So we'll be calculating that with the help of minutes per day of playing video games. So that would be X3, gaming addiction. Well, here is the data that we have on the left-hand side table. We have got the salary projected in 1,000 per month, which means that, if you take the first row, then 50,000 rupees per month as the projected salary of these students who have already got their placement in some organizations. Sense of achievement data we already have, and then we have got the simulated data on gaming duration. So how many minutes per day that the student is engaging in video games, and then the well-being data. So we have that well-being as the criterion variable, and the other three variables, salary, sense of achievement, and gaming addiction, are taken to be the predictor variables. So we utilize the same least square procedure. The equation of the line of best fit is y prime equals 0.02 x1 plus 0.09 x2 minus 0.01 x3 plus 7.23. Now, all these results have come with the help of multiple regression analysis that is based on the least square procedures, and these are kind of calculated with the help of simple software called the Microsoft Excel, although there are other sophisticated softwares like SPSS, that is statistical packages for social science, which also tells us about such kind of statistical analysis. However, the key thing here for us is to understand the whole concept of multiple regression, and that's why we are not going into those softwares right now, but we are focusing on the very statistical principles or procedures with the help of which these can be derived. So that's where we have as the first bullet point, we could derive with the help of least square procedures, the equation of the line of best fit in terms of how y can be predicted with the help of different values on x1, x2, and x3, that is salary, sense of achievement, and gaming addiction. And C is 7.23, which basically means that even if we remove the association of x1, x2, and x3, we find that there might be some internal processes that tells us that well-being still could be high, but then we find that as gaming addiction comes in, it has strong association, negative association, 0.01. And that may nullify again the positive association, which gets reflected in x2, that is sense of achievement, 0.09. So that's the interpretation that we can make. So let's go into it more specifically. So this prediction line, or the line of best fit, helps predict, you're talking about the second bullet point here, predict the value of y, or y predicted, well-being, from any value of any set of values of x1, x2, and x3. Since the regression coefficient of m1, m2, and m3 are actually slopes corresponding to predictors x1, x2, and x3, beg your pardon, a comparative judgment of their prediction strength can be done based on their values and direction. So we can say that the okay, so as the next point, the fourth bullet point tells us, gaming addiction contributes negatively, which is like 0.01 as the slope, unlike other predictors x1 and x2. Now x1 is having 0.02, which is much less slope than 0.09. So if we talk about our earlier question that we asked in regression analysis or linear regression analysis, that what would be the change in y if we bring in change of 1 unit in the predictor variables like x1, x2, and x3 here. So 1 unit change in x1 would mean 0.02 unit change, positive change in y, and 0.09 unit change in y if we have 1 unit change in x2, that is a sense of achievement, but negative 0.1 unit change in well-being, which is perhaps the highest in terms of absolute values of the contributions of the 3 predictor variables for shaping well-being, we find that it is bringing about 0.01 unit change in the value of y with 1 unit change in gaming addiction. So we find that that is not only high, but also in the negative direction. So we find that it's important, although these are simulated data, but it's important to take a look at, again, sense of achievement. We got to increase that for increasing well-being, and we also got to somewhere take care of gaming addiction because it's contributing very highly, that too in a negative manner, towards well-being. So that's where we understand the importance of multiple regression. Now we move on to the final technique of analysis within correlational research, that is known as mediation analysis. So what does it mean? If we have the question that examines the process through which gaming addiction negatively predicts or is negatively associated with well-being that we saw in the multiple regression analysis earlier, then we conduct, I beg your pardon, there is one typo, there should be then we conduct rather than the we conduct mediation analysis. For example, we may have a hypothesis such as the following, that X, that is gaming addiction, is associated with physical or mental fatigue, and that is again negatively associated with well-being. So M is known as the mediating variable or mediator. Well, again, using least square procedures, following regression equations are generated. So X predicting M, then M predicting Y, X predicting Y. If the slopes or regression coefficient of all the above, these three, are statistically significant, then we generate the following regression equation where both X and M are taken to be predictors of Y. I mean, it's actually saying that where um, regression equations 1, 2, 3 are kind of bivariate regression equations or regression equations involving just two variables, we find that equation number 4 involves a multiple regression analysis. Why? Because we find that there is more than one predictor variable. So both X and M are taken to be the predictors of Y, and we try to generate the regression equation there. If the regression equation 4 reveals that the slope of X is statistically insignificant, okay, it doesn't contribute much in terms of its association with Y in the presence of M, because both X and M are given in the equation as the predictors, or the direction of the slope of X becomes different from its slope in regression equation 1, where only, I beg your pardon, it should have been regression equation 3. So that needs to be corrected. It should actually have been 3 here. This particular equation, it should be equation 3. Please take a note of it. Okay. So, all right. Okay. And then we find that if that is the case, then we conclude that X predicts Y with the mediating effects of M. Please remember that what is happening in equation 4, and the condition goes like this, that if the slope of X is it becomes statistically insignificant in this equation 4, or changes its direction from its slope in regression equation, not 1, that's given there, but in 3, where X is predicting Y, okay, then we find that X predicts Y through the mediating effects of M. Or gaming addiction predicts well-being through the mediating effects of physical or mental fatigue. So this was the final one. And after that, I would also like to mention some important considerations related to correlational analysis. I beg your pardon. So continuous variables are utilized here in the correlational analysis. So for example, well-being, salary, sense of achievement, these are all continuous variables rather than categorical variables that are, for example, high or low visibility conditions in which the pilots have to utilize their motor skills or their skills for flying the aircraft, or the types of therapy. So these are all categorical variables, and rather than categorical variables, we utilize the continuous variables in the correlational research, generally speaking. Okay, so regression coefficient or slopes of the line of best fit are comparable, as these are based on standardized scores. So all those line of best fit equations or prediction line equations that we got, these were actually based on standardized scores into which the raw scores of the data on various variables that we had got. So these were converted first to the standardized scores or Z scores, which have the mean of 0 and standard deviation of 1. That's why the regression coefficient could be comparable. Okay, so the term statistical significance that we utilized, particularly in the mediation analysis, and these are also utilized in other analysis that we saw, although we didn't mention that there in correlation coefficient or bivariate or multiple regression analysis, yet it's important that we understand that. So the terms statistical significance of the same sample statistics such as regression coefficient or correlation coefficient correspond to very low probability of wrong rejection of null hypothesis. That entails no association between or among variables under study. So null hypothesis is about no association or no association between or among variables under study. And in order to say that our findings are significant in terms of association, we actually have to not accept or reject null hypothesis. But again, that involves that the whole statistical procedure involves an understanding of whether or not there is a very low probability of wrong rejection of null hypothesis. So for example, if you've got, let us say, less than 0.05 or less than 0.01 probability of wrong rejection of null hypothesis, we say that we have not accepted or we have rejected null hypothesis at 0.01 or 0.05 significance level. So with that, let me also point out that these above mentioned important considerations need to be understood well, particularly for those students who are going to do their projects using correlation analysis. Doesn't mean that it's not important for other students, but since this is not a course on research methodology within psychology or social science, the understanding that we have developed, the basic understanding that we have developed about the whole concept of correlational research and a variety of techniques there would be good enough to understand and interpret the results of various kinds of studies that we are going to utilize in this particular course regarding psychology of well-being. However, again, I would say that those students are going to do a project involving correlational analysis. They need to, again, understand these concepts or important considerations given here on this slide more thoroughly. Well, I'll separately share the reading material for concepts mentioned here on this particular slide with those students. I hope you enjoyed this particular lecture. Thank you very much.